Hello everyone and welcome to this Vecchio service workshop dedicated to natural disasters. My name is Daria, I'm from Novelties, and today I am here to present you a step-by-step tutorial in QGIS focused on a study of a wind outbreak in North America in June 2025. So for this tutorial we will have several parts. First we will look briefly at the context of this phenomenon. Then we will look at the data from a Vecchio service which we're going to use, and then we will switch to QGIS to see the step-by-step procedure. So for the context, here on the slide you can see the outlook of a tornado outbreak on 21st of June 2025, and here you can see the different zones affected by this outbreak. So such outbreaks, tornado outbreaks, derechos, and so on, they are severe convective wind events, and they can cause widespread damage over very large areas. While tornadoes, they produce the most extreme local impacts, the broader hazard usually comes from organized storm systems that generate strong and persistent straight-line winds. So in this tutorial we will focus on the specific event that happened in June 2025, more precisely from 19th to 22nd of June. And during this period the atmosphere was highly unstable. There was warm, moist air near the surface and more cool air above, and this setup favored strong upward motion and deep convection. So when these conditions they are combined with strong background winds and pressure gradients, storms can organize and produce intense and widespread surface wind gusts, which we're gonna see in this tutorial. So understanding these large-scale conditions is essential to better anticipate severe wind outbreaks and improve forecasting and risk assessment. So now let's talk about the data we will use for this event. Here I'm going to the Vecchio website. You'll have all the links given to you in a specific PDF file. So yes, that's also an important note I wanted to tell you, that with this video you also have a PDF file, PDF format of the same tutorial I'm going to present. So if you are more comfortable with just text, you know, like seeing the pictures and reading the text, you can also follow the procedure there, or well, you also have this video, and also all the links will be provided in this PDF version of tutorial, so you can have a quick access to them. So this is official Vecchio service website, and from the Vecchio website you go to the data viewer. Here you can see all the products available, but we will look only on one product that we're gonna use for our tutorial, and it is Era 5 hourly data on single levels from 1940 to present. So the link will be also given to you in the PDF file, but here you can also have some information about the product, and the most important things to say about this is that as we will look at the wind, which is very localized in time variable, we will have of course hourly data, and we will have it for 4 days actually, yes, from 19th to 22nd of June, and we will look at three different variables. So of course the 10 meters components of wind to see the direction and the intensity of the wind. We will also look at the mean sea level pressure, because pressure is very strongly connected to the winds. And the third variable is instantaneous 10-meter wind gust, because well, the gusts are the most destructive and the most powerful part of a wind's outbreak. So now we discussed that too, and we can go directly to our QGIS. So you open your new project, empty, and the first thing we want to do is to actually have a background layer to see a better, good representation of our work. For that we go to Layer tab, we go to Add Layer, and we choose Add XYZ layer. Yeah, it's here. So here I already have a layer which is preloaded, Google Satellite Hybrid. So it's basically how you see a map from Google Maps, for example. And I will just add it, and you can see it behind. Yeah, it's here. But also I could have click on edit and edit it here. So for example, if it's your first time with QGIS, you won't have it, so you will need to like set your own name, put an URL and save it. So this is an URL. You will also have it in your in the PDF file, and there as well you can find several other URLs which you can use instead of Google Hybrids satellite hybrid view. There are also like OpenStreetMap version and many others. It depends on your preferences. So now as we have it, we can zoom to our zone of interest to North America here, and we can start with our product exploration. So first we will look at the mean sea level pressure, and an important note to say is that the data downloaded from a Wikio service are very often in NetCDF format, which is complex but very useful format for the data, because it allows to store several variables in the same file and still have multi dimensions like, well, latitude, longitude, and depth, for example, or height. And you can use import this data from Wikio service and from other services to QGIS with its default function of working with NetCDF files. But in my opinion, it is quite it's not very user friendly. So here at Novelties, we've developed a plugin for QGIS to work with NetCDF files, and we're going to use it. So it's called NetCDF to GIS plugin. Here it looks like that. For this plugin, on how to get it, where to get it, how to download it and install it, all this information you will also have in PDF tutorial. So please don't hesitate to go and check the information before you start with the tutorial itself. So here you can click on plus and then browse to your to the destination where the files are, or you can just drag and drop them. I already have this data here, and we will need this file, which I renamed so it's easier to use it. So it's basically RFI reanalysis. 3 hourly. Yes, we downloaded each 3 hours to save time, because if you're gonna work with each hour, it's gonna be a bit too bulky. And well, you can see that it covers from 19th to 22 of June 2025. And here you can see on the right all the available variables. As I told you, you have U and V components at 10 meters wind. Then you have mean sea level pressure, and you have a instantaneous 10-meter wind gust. You also have this variable called CAPE. I'm not gonna talk about it specifically because it's not exactly a tutorial, but it can be an additional exercise for you later. So here we have all our variables we are going to look at, and as I told you, we will first look at mean sea level pressure. So it's this one. And even though we will look at one variable in this exercise, we will still use a very specific function of this plugin. When you choose MSL, you right click on it, and there is 3 options: add layers, sequence layers, and add layers of several variables. If you want to add layers only of this variable, you would click on the first one. The sequence layers is just to see the kind of the animation of the layers you want to add, and this one is to add several variables, as it says. So we click on it, and here it allows us to choose several variables, which we choose MSL and this one. You just click on it, you go to next, and it will open you 2 windows in which you can choose your the time frames you're interested in. So we will work with MSL. So we're gonna choose all the time frames we have. There are 31 time frames. So we click on the first one, we hold Shift, and we click on the last one. So all of them are chosen, and you can see that in the second window they will also be all selected. So we click on Add and Close here, and both windows they disappear, and we have here both MSL and I10 FG added with all the time frames selected. Like this, it allowed us to avoid going twice to the same plugin and choose do the same procedure with both variables. So now let's start with our mean sea level pressure variable. So we will untick this box, close it, and we'll focus only on this layer. So first, let's adjust the style of the layers so it is more representative and easier for us to correlate between different layers. So we'll double click on the first time frame we have. We go to symbology, it is here, and we will choose the following settings. So here we have a single band pseudo color, yes. We will choose a color ramp spectral, and we will invert it from blue to red. Now it's from red to blue, so we click on this little arrow, invert color ramp. We will make it equal interval. We will keep 5 classes only. Oops, 5 classes. Okay. Label precision 1 is enough. And min and max we will set as like this, and here it will be 102500 like this. Okay, now we click on apply, and you can see behind that it changed to this style. We click on OK, and now we want to have the same style applied to all our time frames. So for that we right click our the layer we just changed. We go to styles, copy style. It will say all style categories or other. We usually just copy all style categories, and then we click on the next one. We hold shift till the last, and then right click, and there's a paste style appeared here. We do that, and now if you untick each box slowly, you will see the progression of mean sea level pressure, and you can see how it moves, how it's here, for example. We can see that in a kind of central part of our zone, we can see that the pressure drops. If you want to see the scale, it's like that. So you can see that it's slowly started to drop around, I don't know, yeah, I guess, yeah, at night, 20th of June, it started to drop. You can see how it still quite low in this area and fluctuates around, and then it slowly kind of closes, but still kind of fluctuates as well, and yeah, grows back again, starting from like, what was it? Yeah, from 22nd of June at night also. So you've seen that. So now we've seen the development of pressure during these 4 days, and we now want to have we want to know how can we use this information during the peak of this outbreak, right? Like to select to locate the peak of this outbreak in order to see the correlation between this variable and then with other wind conditions, which we have a direction, intensity, and we also have a gust. So for this, well, first we will look at the combination of mean sea level pressure and the gust, instantaneous gust variable, which we already added to our project, but we'll look at it in the next exercise. For now, we will focus on preparing another layer based on a pressure layer, and which we will then use for analysis. So here what we want to obtain contour lines which delimit the zones of the same pressure levels. So like isolines basically. And as you've seen already, the progression of the outbreak, we'll focus only on one time frame, which we selected to be 21st of June at 6 o'clock in the evening. And because, well, it's more or less, it corresponds to the peak of a studied event, but don't hesitate to choose another date, or maybe to choose several dates and make the same analysis of several dates, and this will only enrich this study, but we just don't have that much time, so We'll focus on one specific date, as I told you, so we will untick all others. I need 21st of, yeah, this one. Here you can see a very specific, very located low pressure zone. So we ticked it, we also highlighted, so it's going to be easier to work with it. And now we're going to our processing toolbox here. Well, usually it is actually closed, but you will open it with this little gear icon here. And we will search here for contour. And here in the GDAL plugin option functions, we will have a contour. We double click on it. And in the pop-up window, we will set the following settings. So input layer is this one. Yes, it's already selected because we highlighted it before clicking on, before going to processing toolbox window. Interval between contour lines, we will set it to 100, otherwise it will be too saturated, because it's basically how close the lines are together. Then it is not elevation, we will set it to MSL, and then you can save it to a file. Well, basically all the calculations you can perform with different features of QGIS, you can either save them to a temporary file, so it will be saved on your computer, so the next time you open your project it will be already there, or you can use it in different hours projects in QGIS. Or if you don't save it and you just save it to temporary file, like you don't set here anything, it will be saved only for this session in QGIS. So as soon as you close QGIS, all the temporary layers you've created, they will of course disappear and won't be available for the next time. So let us I already prepared the name here. We will save it to a file. So I've prepared here a little new folder. For that's gonna be the name, contours, well, at 21 of June at 18 o'clock, and it's gonna be shape file, so it's gonna be a vector file. We'll save it, we click on run, and we close it, and we see the new layer just been added. I will drag it on top like that, and if you zoom, you can see already their contour lines appeared on our layer. So now let's adjust it really quick so it is more representative. First, let's change color to black, if there is black. Some, yeah, well, it's kind of purple, but okay, will work. And maybe width just a bit. No, maybe it's too much. Okay, let's keep width to 3, for example. Okay, now we can see that the lines change the color and they become bigger. And also if we go to labels here on the left, you can choose single labels. And think you just click on apply, and now you can see the labels added, but that's not the labels we need because it's not, what is it? Ah, it's ID. Yeah, okay, in the value you need to choose MSL, of course, because we are interested not in ID but in the value of mean sea level pressure. We click on apply. Well, now it's better. Okay, and now you can see that each line, well, not each line, but yeah, like if you zoom, it's going to be each line. If you unzoom, it's going to be less frequent. Each line has its value written here in black. And you can see basically you can see which pressure is allocated to each lines. So yeah, this is just a superposition of the same layer. So this colorful representation of pressure and also the ISA lines, they just well, help visualize, help identify the structure of a pressure field more clearly. And yes, as I already said, the ISA lines, they allow to trace areas of equal pressure, and well, allow us to see how the pressure is low pressure system is organized here in the middle, which we are more interested in. And also, which is most important, is the gradients, because because for us, we are not specifically interested in low pressure or high pressure zones, but we are interested in high gradient of pressure, because exactly this gradient is responsible for strong winds. So the gradient, what gradient means? It means the most rapid change in pressure. So for example, here on the graph, that's exactly why we chose isolines, because the closer the isolines are, that means the faster they change. So you can see, for example, here, this is going to be the highest gradient we actually have, because the lines are super close. Like if you unzoom, you can see how dense this area is, or like here, for example. Also, like here, you can also clearly see that the lines are much more close to each other than, for example, here, meaning that here we have a strong gradient, and we will see later if our theory is correct, and we will see it with wind gusts layer. And so we are moving to this second exercise. So we are moving to wind gusts, exactly. So yeah, in this exercise we will map them and see the correlation between them and the mean sea level pressure, which we already plotted. So just to remind you, wind gusts, they represent sudden increases in wind speed, and they are responsible for most of wind damage at the surface. And comparing these wind gusts with pressure patterns, we can see how rapid changes in pressure area, as I said, they are linked to stronger winds. That will help us understand where exactly the most intense impacts are likely to occur during severe weather events. So, as we already mapped our layers of wind gusts, we're gonna just activate them. We're gonna hide this one and open all our timeframes for the wind gust. We double click again to go to properties, and we will say we'll repeat the same procedure to adjust the style for the wind gust. So for the color, I think we will choose turbo, and we also keep it from blue to red, so it's good. Same equal interval, we'll keep it at 5 classes. Label precision 1, I think, is okay. And for mean and max, well, we will keep it at 0.7, and max we will keep at 23. Like that, we will apply. Okay, so that's our new changed style layer. We do the same, we go to style, scopy style, all style categories. We choose all our time frames, and we paste the style. Same, let's untick the boxes to see what changes. Here, well, again, if you want to look at the scale, so red patches are the most rapid winds, and well, bluish, they means most calm ones. Okay, we also kind of see the patterns of the wind. You see when they move, we see how they swirl and turn. And here, basically from midday of 19th of June, we already see that there are some winds appearing. Then they calm down a bit, and then from midday of 20th, they start to grow. Or they start to grow a lot. You can see a lot of red, kind of bit fluctuate and start to localize here in the middle-ish, kinda, and kinda stay there, grow, fluctuate again. And just like that, you can see that, well, most of the time you can see strong winds, strong gusts, more or less located here in the middle lower part of our studied zone. So yeah, as you've just noticed, we had quite low gusts in the beginning of a period. Then they start to increase. They were organizing into broader patterns. Then they were fluctuating a bit, like going down and then going back up again, as you've seen. And more or less, we've noticed that around evening of 21st of June, we saw that there's kinda peak conditions. For example, in the evening, sorry, 18th, for example, which we already looked at mean sea level pressure, and then you can see at 9 also, and then it starts to slowly go kinda down. So as we looked at our mean sea level pressure at 6 o'clock in the evening on 21st of June, we will activate this layer. Let's close this and zoom a bit like that. And we will activate the same layer, which is this one, to see the patterns, to see the correlation between the two of them. And exactly what we wanted to see, exactly what we were saying before, is that both patterns, they kind of align, not to a point. Of course, there are some differences, but we do see the main point that we wanted to show to you is that strong winds, they do not occur simply where the pressure is high or low. Instead, the strongest gust winds, they appear at the places where pressure isolines are closest together, so where we have a stronger pressure gradient. So here, for example, as I told you, it's quite tight here, right? And also here. So basically, yes, the red zones of wind gusts are corresponding to more tightly spaced isolines of mean sea level pressure. And now that we have identified this relationship between pressure gradients and wind gusts, we can shift the focus from atmospheric dynamics to potential surface impacts, because that is what is important to see how these winds, how these outbreaks actually influence people, basically. And rather than working with raw wind values, like how it's 25 meters per second or something, classifying wind gusts into intensity levels, so by specific margin, by specific threshold, that actually help us translate meteorological data into information that is easier to interpret in terms of hazard and damage potential, for example. And in this exercise, in the next exercise, we will do exactly that. We will group the wind gusts into simple, physically meaningful classes like strong, damaging, and severe winds. And this classification will allow us to map where the strongest wind occurred and assess how localized they are, and better understand the footprint of such winds, of such the hazards of these winds associated with this event. So for that, we will create a classification raster, we'll call it like that, and we will go back to our time frames of wind gusts, and we will right click on the group and we will click on check and all its children. So basically it means that all the layers into this group will be checked in again. I will hide the contour, and let's look through them quickly again to spot really the highest winds, highest gusts. We can see this. This is not far. Well, this is quite. Yeah, this is our date, right? But actually, the next 3 hours, so not the 6 o'clock p.m. on 21st of June, but the 21, so like 9 o'clock p.m., 9 p.m. o'clock, sorry. This has higher values here, especially here, and then I think it goes down. Yeah. Okay, so we will stay on this time frame, and we will verify that it is exactly the one with highest values by double clicking on it, and we go to information, and here you can have all the stats of it. It's minimum, maximum stuff, and like that. Here you can see that maximum was all like 26, right? And for example, if we double click on one that we worked with before, you can see that it's only 23, so it is lower. You can also do for each time frame if you want, just to verify. But yeah, we can see 22, somewhere here it's 22 also. So yeah, I think we are all agree that on this time frame it is it is the peak conditions for our wind gust. So we will keep this this layer and we'll work with it. And as I told you, we will have classification, quite simple one, very simple. Is we will have 4 classes. So first class will be weak or like background wind, like no wind, like nothing special. Second one will be strong wind, then it's gonna be damaging winds, and well, severe wind. And for that classification, I will show you a formula and then we will talk about it a bit more. So we go back to processing toolbox and we search for raster calculator here. Double click and here it is. We will need to first choose the input layers. For us it's only one layer. It's yeah, it has all the layers loaded to the project. We need wind gust on 21, this one, right. We click on OK. We will set the CRS as the project one. We will quickly save it in our folder. I already give it a name, very simple, wind classification. Okay. And the expression is the most important part. So the expression, I will also copy paste it from the PDF which is provided to you. You can do the same or do it manually as you wish. So basically here you can see the expressions to have this classification. So we decided that weak winds, they are going to be less than 15 meters per second. The strong wind is between 15 and 20 meters per second, damaging between 20 to 25, and more than 25 is going to be severe wind. And here you can clearly see it. So what we are doing is we're saying, okay, so if the winds, the gusts are more than 15 but less than 20, then it's class 1. If it is between 20 and 25, it's 2, and if it is 25, it is 3, meaning that if it is none of it, so less than 15, then it's 0 and it's not stated. So like this, we'll have 4 classes. We click on OK. What is also can be a nice exercise for you guys is to maybe play around with this expression and set different values of like choose different thresholds yourself to see how it will impact, how it will change our classification map. But we're gonna stick to this one, and we can run it. It saved it here. I will drag and drop it above. It looks like this, and we can close this window. Well, now you can see we have a new raster file with a raster layer with different shades of gray, actually, which is not really nice, maybe not really representative. So let's adjust the style once again. Double click, and now we will choose different render type. We're gonna choose paletted or unique values like that, and we will set random colors. Okay, classify, and we now have 4 different colors for random colors, bright and beautiful, each with its own value, so 0, 1, 2, and 3. And I think what we will do for just a better representation, well, let's set the 0, 1 to just white. Is there white? Okay, I'll do like that. Okay, so we have basically, if there are no winds, it's gonna be white, and the zones with other labels they will be colored. Or for example, what you also can do, you can make it fully transparent like this. Let's see, apply, and that's exactly how it looks like. Well, it's overlaid with our gusts for the same time frame, but you can see different colors here. And also what I was thinking, yeah, I can show you. Well, now you have here the label corresponding to the just a class, right? But we can actually adjust this label by saying, for example, less than 15, 15, 20, 20, 25, and more than 20. Sorry, more than, no, sorry, 25. Like this, apply, okay, and you can see that the legend here of the layer has changed. Let's take it like that. So basically, this is what we get. So yeah, there's no when there's no significant wind, it's transparent. In purple, we have a strong wind. In red, we have damaging, and very severe winds we have in green, which is a very, very small area somewhere here in several pixels, right? So from here, what we can see is that indeed the biggest area the biggest area is the one that's covered by only strong winds, and then there are some smaller localized patches of damaging winds, and then we see that severe winds, they remain very limited to a small area just here for this specific time frame. But as I told you, you can try to do exactly the same procedure of this classification raster, but for maybe other time frames, to see how this classification is how is it shown for different time frames with different gusts conditions, and also play around the thresholds for the classification to see how this will impact the representation of this classification. So that's it, and this again allows us to spot the regions that are most affected by the gusts, where we have less strong winds. And now let's see actually how big are those areas in a quantitative way, so with a number, so basically with an area of a zone which is impacted by specific winds. So for this, we would need to work with polygons, so with vector files, vector layers, and this layer is raster layer. So first we will need to polygonize our raster layer to have vector layer. For this, you can either just put it here and type polygonize, or you can also go to raster here tab, go to conversion, polygonize raster to vector, and we have wind classification, name of the field, indeed it is wind, and you can save it to a file. I called it wind map, I guess. I'll save it, I run it. Oh, it did not work. Well, it did work, but it gives us some error. Oh, sorry. Okay, let's see. So here it created a new layer, and that's usually how it looks like. It's basically the whole raster layer we had, which is now a vector layer. You can also right click on it and open attribute table, and you will see that basically it consists of many small polygons, and each of them has its own class, like 0, 1, 2, and so on. And yeah, if you zoom, you will see that there are many small polygons also, like these ones, for example. So next step would be to dissolve our layer into 4 different classes. And you can say that, oh, it's already 4 different classes. Yes, but as you've seen, we had many lines, many small polygons, because even though we have only 4 classes, we still have many small pixels or some zones that are the same class, but they are separated. So we want to dissolve them, and for that we will look at vector, yes, geoprocessing tools, dissolve, and it's wind map, and dissolve field we will choose wind, so it knows to dissolve it because I think if we don't choose the field, it will dissolve everything in one, so we just have a rectangular of one value, I think. And let's save it to file, and we'll call it winmap, but with underscore clean. And I hope it will work and we won't have problems. Oh no, seems like it works. Okay, and now if we right click again and go to attribute table, yes, you see now we have only 4 lines, so only 4 polygons, each having a specific class that we chose. And now next, as I told you, we want to calculate the area, but first an important thing to note and to not to forget to is that our CRS, which is coordinate reference system, is this one, 4326. And if you also move your cursor on the map, you can see that the coordinate here down changes, and it is in degrees, so in latitude and longitude, which means that if we will calculate the area right now, it will give us area not in square, like kilometers, meters, whatever you want, but in square degrees, which is not very representative and not really clear for us. So we will double check it again, because we'll just double click on our layer, go to properties, information, and check the reference system. It is exactly the same as a project, which is normal. It's usually like that. So first we would need to change our coordinate reference system, so reproject it to then calculate the area of our zones in more natural area units, like in kilometers square, for example. So for that, it is enough for us to just right click again on our new layer and go to export and save features as. It will allow us to save it as a new file, and it will allow us to reproject it as well. So with format, we will keep it as a shapefile, file name. Let's browse where we have our layer, and we'll call it reprojected. Okay. And of course, the most important is to change the CRS here. This one, EPCG 5070, is the one we need, Conus albers. I don't know if I pronounce it properly. But if it is not here by any chance, I don't know, sometimes it is, I guess you would need to click, yes, you need to click here and find it in a list here, or just, as I told you, it's 5070, you will just put it here. So basically that's the projection that covers exactly more or less USA, yeah, not even North America, but USA. Okay, so we check this, we named it, check this, okay, we can click on OK. It, yeah, show us, okay, we click on OK, and there's a new, basically the same layer created, but now if we double click on it and go to properties, we see that the CRS of it has changed. And now we can calculate the area. So we need to go to attribute table, right click, open attribute table. It has this one, it's a bit too big, let me adjust it. And here you can see this little icon, which is called field calculator. We open it, and this new window, we will create a new field name. We call it area, we will put it as a decimal number. Precision, I think is okay, yeah. And the area is calculated as, well, usually you can even like search it here, area, this one. What is that? Okay, area, and we want to divide it by 1e6, so we want it in square kilometers. Okay, and you can already see the preview for the first feature, which is 0. So here you can see that, oh, it's a big number, 5,082,138 square kilometers is covered by 0, class 0, which means, well, with low winds, which is quite expectable. Then with strong winds we have, I'm sorry, that's 1.5 million basically. With second, which is damaging winds, is 268,000 square kilometers, and with free it's only almost 1,200 kilometers. Okay, so we click on apply, click on OK. Oh, sorry, yeah, we already added it. So a new column has been added to the attribute table. Here you can see it's called area with the values here. And that's basically how we calculate it. And before we finish with this step, we need to click on this little editing mode icon, or its little pencil, and it will ask you if you want to save the changes you've brought by calculating new field. You click on save, and now this new column, this data has been written to your file, your shape file, which you have saved externally, so it will keep this information. So just from this exercise, what we can say that, well, even though we've seen very high gusts, high wind conditions all over the zone, the study zone, we can still see that only a small fraction of the area experiences winds that are intense enough to be classified as damaging or severe. And also, well, that highlights the localized nature of this the most hazardous impact, which means that even though the winds are strong, the winds are fast here in this region, it's still the highest impact, the most dangerous part of this wind is quite localized. So that's it for this exercise. And now next exercise, which is fourth exercise and the last exercise, is to show you how to calculate wind vector field, because as I told you, we had gusts, so the intensity, the speed of it, but also we would like to see the vector field of wind, so how like the direction of wind and its intensity as well. And for that we will use our NetCDF2GIS plugin, which I already showed you, which also allows us not only import NetCDF files, but also to create vector fields, which is very useful, because again, in QGIS default functions and features, there is something to calculate vector fields, but it's a bit it's less user-friendly as well. So we go to our plugin. It's already open, right? We didn't close it. We go back to NetCDF, and here we have these two variables, U10 and V10, which is U and V components of wind at 10 meters, which is exactly what we're going to use. And let's calculate vector field for this wind for the same date we already looked at what was it? It was June 31st of June at 6 in the evening. So again, we right click, add layers of several variables, because we want U10 and V10. We go next, we go to these windows, and in U10, let's see, what was it, 21, this one. Yes, and if you scroll down for the V10, you also see that it's been selected. Add and close. Okay, great, it's added here. We are not particularly interested in these layers in raster version, because they do not really tell us much. So we untick them. Also can untick this, and we go back to our plugin. I'm sorry, it's been like this. And now, not in this NetCDF tab, but in Layers tab, you can actually see all the layers that have been added to this project. Even if you remove them from the Layers tab here on the left, they will still be tracked down here in the plugin, showing that they've been added with this plugin. And here in at the end, you can see U10 and V10. So what we do now is we click on U10. We hold Ctrl, we click on V10, so they are both selected. We right click, and here you have several functions. We're not gonna talk about all of them, just vectorize function. Here you click on it, and it gives us a new dialog window, which allows us to vectorize two rasters, which give, well, these rasters, if they represent the U and V components, which we have it here. So layer U is our U10, layer V, okay. What is the norm? It's not the current, it's wind wave. And then there's downsampling. And downsampling is basically, it's a factor that allows us to make the display less busy with arrows, because what this tool will do, it will create us a vector field. So it will create little arrows with wind direction. And if there are too many arrows, it might be a bit too busy, you know, so it's a bit hard to really understand what's happening. And the downsampling basically means, for example, if we choose, well, none will be applied, but if you choose like X10, it means that instead of 10 arrows, it will show only one. You know, like instead of 10 pixels, only one big pixel, kinda. So we will here apply only X5, I think, and we will save it to our folder. And we will call it like that. Oh. We click on vectorize, and it worked. We can close it up, and now you see exactly same extent of our study area. We see many colorful, pretty arrows. So if we superimpose it with our wind gust layer, so this one, no, we should choose one at 6, yeah, this one. We can see the correlation between, but the color is not, well, let's change the color of our arrows again, double click on them, symbology, and let's go for something darker like magma, for example. Yeah, that's better. So have better contrast between two color schemes. So now we can see the correlation between the gusts and the intensity of winds and direction. Well, mostly in intensity, because you can see, for example, well, darker colors of arrows means slower winds, and well, faster winds are in lighter colors. And you can see that basically when it is bluish on the gust, so on the background, the arrows are also quite dark, and then the gust increases to its highest values, like in oranges and reds. You can see that the arrows also become more in more lighter colors, like for example here it goes to pink and also goes to yellow. For example, here you can see that yellow arrows, they basically mean the highest wind intensity, and it corresponds to basically to the most red parts of a wind gust layer. But another thing to note is that wind direction, like we see the arrows, what shows us where a wind goes. Wind direction, however, does not clearly control gust intensity. So yeah, you can see that well, the gusts are driven by, well, local turbulence, like a pressure again, right? Rather than, well, large scale flow direction, because, well, flow direction is large scale here. So that was it for our last exercise, and now I just want to say briefly that you can have some further exercises to further deepen this topic, to deepen your knowledge of QGIS, of data from the QGIS service, and also just to play and to make this exercise a bit, this tutorial exercise longer and I don't know, more detailed. You can explore on your own, add whatever you want, and make it the way you wish. I will give you some suggestions about some further exercises. For example, based on this raster calculator function, which we already used before, you can well, I showed you how to do classification map, right? But what you can do, for example, is you can calculate daily means of the variables we studied. For example, we had 3 hours, like each 3 hours of 4 days from 19th to 22nd of June. What you can do is with raster calculator, you also can calculate means. So to see the, for example, mean sea level, mean sea level pressure per day. or also with gusts. And what else? Another exercise is, as I told you, you can play with different thresholds to create different classification maps, but also you can create classification maps for other timeframes. You can also create other isolines, you remember contour layers for other timeframes also to see how it and compare it with gusts as well. And another exercise, another option is of course to download more variables from the Wikio platform and add them to the analysis. For example, as I told you in the beginning, in our plugin, we have this value, this variable called CAPE. Well, CAPE actually means conductive available potential energy, a bit complicated name. For example, it's already downloaded, and I think this file, like this data, will be provided to you as well, so you don't need to download it all over again. And you can try to plot this variable, play with it, also overlap it with variables we already have to see how it correlates and make your conclusions. Or for example, you can download, well, temperature, right? Air temperature. You can also calculate maybe even soil temperature. Who knows? Maybe it is also connected to the wind outbreaks. And precipitation, total precipitation also might be interesting to see if these wind gusts, they were just destructive winds, or they also brought like storms with a lot of precipitation, a lot of rain. So that's it. Again, do not hesitate to check out other QGIS tutorials on the Wikio platform. Yes, to find inspiration, of course, and also to find some more instructions, because it is true that there are many other tutorials that have been made about other topics on Wikio, so you might actually see how our tools of QGIS are used with the data from Wikio, and maybe some of them can be applied to this tutorial as well. So yes, that was it. We learned how to do a lot of things with data from Wikio service, which was an indented format. We learned how to map it, we learned how to change its styles. We changed a lot of styles today, how to compare them, how to correlate them, how to overlap them, how to create classification maps by threshold using raster calculator. We learned how to pass from raster layer to vectorize it, to clean it a bit, to do a calculation of area, right? We saw how, what area is covered by which type of wind. We learned how vectorize raster layers to have a vector field. And what else have we done? And we also plotted isolines, so contours of raster layers. And that was it. That was all the features we wanted to present to you today. I hope you enjoyed it. I hope you learned something new, whether about QGIS or whether about data. And yes, I hope you enjoyed it. And well, go on and try it now yourself. So thank you very much for your attention, and yeah, have a nice one. Bye bye.